Okay guys, in this video what I wanted to go over quickly was weather prediction. And I forgot to mention in one of the other videos, these concepts are not in your class notes, but there are concepts that you're accountable for. So it would probably be a good idea to just write some key ideas down. These videos will be posted. I'm not going to take them down, but it might be a good idea to kind of jot some notes down to go along with your set of class notes as we proceed. But what I wanted to do today was to just talk about weather prediction, how we actually make the forecasts that are used to predict the weather. And there's a few different approaches that we could take. And the first one we'll take a look at is what's called the persistence approach to forecasting. A very silly concept. However, it actually has a pretty good accuracy rate. The idea with persistence forecasting is that, well, you simply say the weather tomorrow will be the same as it is today. And even though this sounds ridiculous, you'll be right 50% of the time. So that's essentially where we're starting out with weather forecasting, is we're trying to get better than 50%. You know, anybody could say, well, the weather today or tomorrow is going to be the same as it is today, and be right about half the time. It makes sense that 50% is about where that's at, too, because, well, if it's a raining snowstorm, or let's say it's a snowstorm, there's a good chance that storm is going to still be affecting us the next day. And that's really where the 50% comes from. So we're trying to improve and get better than 50%. But that's kind of like a starting point. And this simple concept is what's called persistence forecasting. Even though it sounds silly, you'd still have an accuracy rate of 50%, which might sound terrible. And it kind of is. At the same time, though, our best accuracy rate is 80%. So it's the difference between 50 and 80. So we're talking about 50, which is just a guess, really, and 80% using all of our supercomputers and all our technology. You know, something to think about. So the persistence forecast, the limitations with it are that even though you're right half the time, you're going to be wrong half the time. That's the biggest problem with that. The second approach involves using the synoptic weather maps. Okay, and this is what you're doing in your weather patterns lab. Okay, remember synoptic means synopsis. Okay, so again, they're synopsis of the weather at a given time. And these are the maps that we've been working with all along. Here we can see a cold front, a stationary front there, low pressure, high pressure. And when you look at a weather map like this, you kind of make an interpretation as to what you think is going on. This use of weather maps is a useful tool for figuring out what might happen in the future, but it is limited. For one thing, these maps are only useful for a couple of days. After that, they're not useful anymore. There's a lot of variables that are not accounted for in these kind of maps. Things like local terrain, where there are mountains, maybe there's large lakes and rivers. Those kind of small-scale features will affect the weather, and they're not accounted for on a synoptic weather map. They're also subjective, meaning they're based on opinion. So I might look at a weather map, and maybe another earth science teacher would look at the same weather map and maybe have two different opinions about what might happen. And this happens with professionals too. One meteorologist might have an opinion about what will happen, and another one would have a different opinion, and a third one might even have a third opinion. And they're all ideas based on science, but only one of them is going to be right, and there's no way of really knowing which one. And that's one of the limitations of the synoptic weather map. Okay, the third approach involves what's called a numerical weather approach. And I guess this picture is getting a little outdated with the large computer monitor there, but the idea is still the same. We're using supercomputers to perform literally billions of calculations in an attempt to predict the weather. The way that this works is based on physics. And it's the same physics that we would use for things like laws of motion, determining where planets are, and things like that. And the idea is that you apply these laws of physics to small areas. So we look at the weather data for a small area from a weather station, and then based on the data that's collected, we use mathematical models to make a prediction about what's going to happen just a little bit to like the east. And then based on that prediction, we build on that and make another prediction and another prediction and another prediction and another prediction. So essentially what's happening, it's almost like a chain reaction where you start out with some data, and then building upon that data, you make many, many mathematical predictions to ultimately build a forecast. Now, this approach has a lot of advantages. And when you go to a website like weather.com, Weather Underground, NOAA, something like that, you type in your zip code, and what you're really accessing are these numerical weather predictions. There's only a few facilities in the world that make these kind of predictions, and this isn't a very impressive photograph, obviously, it's kind of older, but there's only a couple places in the United States that can do this, Europe, in Canada, and these are the forecasts or that all of these different websites use. They're all based around these supercomputer numerical models. These computer models, even though they're very sophisticated, do have their limitations too. And as we saw many times this winter, they didn't get it right every time. There were certainly flaws. They couldn't tell which model to use sometimes, and then sometimes the models would do unpredicted things. So there's a number of limitations with these. If you ever take a class in computer science, there's a common term or a phrase, garbage in, garbage out, which essentially means that if you're writing a computer program, or in the case of the supercomputers in this case, your product is only as good as what you put into it. So if you start out with data that's not very good, you're going to end up with a product that's not very good too. And that's what's meant by garbage in, garbage out. If the information going in, if the data wasn't collected very well, or there was a slight error in the beginning, that error or mistake is going to get carried out through all of the calculations. And it really is billions of calculations. This idea of numerical weather prediction is not new, and it actually goes back to a much earlier time. I think around the 1930s or 1940s or so, well before the time of computers. And the problem and the reason that this wasn't used until computers came along is that doing the billions of calculations was so labor intensive that it would take a team of about 30 people something like a week or two to do all the math. And it would take that much time. And at that point, the weather has come and gone. There's no point in making a forecast anymore because the weather has already happened. So that's one of the limitations of the numerical weather prediction model too, is there's so many calculations. You have to have a supercomputer to handle them all. If you try to do it by hand, it's so labor intensive. It's going to take so much time. By the time it's done, the weather, there's not going to be a need for a forecast anymore, or whatever's going to happen already would have happened. So the entire process depends on a good start. If you have poor data going into this series of equations, your final product, your final answer is not going to come out right. And that's one of the problems. Another limitation of this is we have what are called data poor areas throughout the country. There's areas where we just don't have a lot of weather stations and a lot of instruments to monitor the weather. Think large expanses of forest, deserts, unpopulated areas, large bodies of water. There's really not a lot of weather data being collected in those places. And that means that we have areas where there's clusters of lots of data, and then areas where there's just large expanses of little data. And the computer models try to fill in the gaps where there isn't enough data, but that is a limitation. And computer models also don't factor in small-scale variables. Things like cliffs, mountains, valleys, lakes, rivers, all of these small things will have an impact on the weather for localized areas, and these weather models don't take that into account. And I mentioned this once before, the statistical model, and this is Jim Witt. He's the guy that developed this weather calendar. And he, again, looks at old weather records and tries to make a prediction for the future. He can only do this for specific locations. So his calendar will, again, tell you the weather for the entire calendar year. However, it's very specific to location. And his calendar only works for the Hudson Valley region. If you took his calendar out to California, if it has any use, it would have no use there. And I say if it has any use, this is kind of a controversial method. Its reliability is relatively low. It's more of kind of a fun idea. However, he claims that if he has enough weather data, he could get his accuracy level to that of the supercomputers. Whether or not that's true, it's impossible to prove, because the real limitation with the statistical model is there's just not enough data. We've only been keeping weather records as human civilization for maybe 100 years, tops 150 years, which really isn't that long. I mean, that's like, your great-grandparents. So that's one of the problems with the statistical model is we just don't have much data to work with. If we've been keeping weather data accurately for thousands of years, there might be more to it than there is at this point. So maybe someday, maybe 1,000 years from now, statistical model will work great. But at this point, it's not reliable enough to accurately predict the weather. However, it is interesting, and maybe in the far future, it will become more useful. So that's a little bit about weather prediction. So that's it for now.